Hey geometry students. So today we are going to be looking at 9-6. We're going to be looking at dilations. So our lesson objectives today is we're going to be drawing dilations in a coordinate plane. So if you would like, there's graph paper on Schoology that you can print off to help keep your notes neater. First, go ahead and try the bell ringer. All right, so for the bell ring, for the first one, there is no symmetry. For number 2, there are 2 lines of symmetry. One would be right here. The second one would be there. For number 3, the figure has rotational symmetry. We can state the order and magnitude. So it does have rotational symmetry. The order is 5, with the magnitude being 72. And for number 4 as well, yes, it does have rotational symmetry, order of 8, and a magnitude of 45. So looking at dilations. So a dilation occurs when you have an original image. So in this case, we're looking at LMP, a triangle here, and it is being dilated by a scale factor of K. So a scale factor K refers to how much the point is going to move. So if we look here, we've got our center of dilation, point C, and LMP is being dilated to L prime, M prime, and P prime. Now what you notice here is P prime here, it lies along this ray CP. Likewise, CL or L prime lies along the ray LC. So we can, when we're mapping dilations, especially in a coordinate plane, we know that we can draw a line from point C to point L and going on, and our L prime point will fall along that ray. Just like with M prime falls along the ray CM. Now, at what point? So here we're looking at a scale factor of 2.5, right? So it's 2.5. What that means is the distance between C and P prime is going to be 2.5 times CP. Like we get here, CP prime is equal to 2.5, which is our scale factor, right? Scale factor K, times the distance here of 4, and so we get the distance of CP prime is equal to 10. So let's look at this here. Copy triangle ABC and point D, and then use a ruler to draw the image ABC under a dilation with a scale factor, with a center D and a scale factor of 1/2. So go ahead and try this first. So now we know that B prime, A prime, and C prime are going to fall along these rays here. Now our scale factor being 1/2, meaning the distance between B and D is going to be cut in half. So again, we can measure that using our ruler. And so what we see here is our translated or our dilated triangle, A prime, B prime, C prime, and the distance between our center and the point has been multiplied by a scale factor of 1/2. Now, likewise, dilations on a coordinate plane. So our original coordinates, in this case, we'll look at here, point P. Point P here, 2, 3. Now what happens is our coordinate plane, or our coordinate is multiplied by a scale factor here, and so what we get here is 2 times 2, 2 times 3, with our new dilated point at 4, 6. And you do the same thing here with point M and M prime as well. So that is again how we get from our pre-image to our image using the scale factor of dilation, which is our K. All right, here we're looking at an example. I've already taken the liberty of drawing in our lines here, our arrays along from our center of dilation at our origin. So again, if we have a scale factor of 2.5, we're going to multiply every coordinate point by 2.5. So our J prime is 2.5. The distance from the origin as J, M prime is 2.5 times the distance of M, L and K, and so on. Again, try this out if you are a little unsure about what's going on. Try it out on your own. Again, here we've got a scale factor of 1/2. Again, I've taken the points 1/4, and I've taken the points and brought them back 1/4 using M as our center and a scale factor of 1/4. So this point here is 1/4 of the distance from M as this point. This point here is 1/4 from this point, and likewise. And then this would be a reduction, right? So here we're talking about a reduction, and here we're talking about an enlargement, because K is greater than 1, and here K is between 0 and 1. So go ahead and try this. Determine if it is an enlargement or a reduction, and then find the factor of dilation. So we're going from B to B prime. So we notice here that B prime is farther away, right? So that's going to be an enlargement. But what is the distance? Well, we can find the distance. We can find our scale factor K is going to be the distance of B prime divided by B, or 8 divided by 6. So our scale factor here is 4/3. Once we know our scale factor, we can find X. So obviously X here is going to be 2, right? X is going to be 2. 2 plus 6 equals 8. All right, so a bit of a shorter lesson again for us today. This is what we're working on. We got 9-5 practice problems from last class, and then some new ones, just 5 from today. Again, there is graph paper on Schoology if you'd like to print that off to help keep yourself more organized. Do use a straight edge when you are graphing these and dilating these. Thanks for listening, and I'll see you on Tuesday. Bye, everybody.